In this video, we're going to talk very briefly about what is inside a router, and we're also going to talk about packet forwarding. So, at a very high level, this is what a router looks like. Okay, you're going to have some input ports, you'll have a high-speed switching fabric, and then you will also have some router output ports, and then you will have a routing processor. Now, the routing processor will implement the routing management control plane, and typically this is implemented in software and it operates on the scale of milliseconds. The forwarding data plane is typically implemented in hardware and it operates on the order of nanoseconds. So you have your routing processor will compute forwarding tables and then push those down to the router input ports. And those tables are then consulted to determine where the packets go when they come in. So let's talk a little bit about destination-based forwarding, right? So these are IP version 4 addresses. IP version 4 addresses are 32 bits long. Typically, each of these is considered an octet, just 8 bits. Okay, and you can see here, we say if the destination address is between 11001000 00101111 or 0001 followed by quadruple 0 or and that to this number, we're going to output it on output port 0. If it falls in this range, we're going to output it to output port 1. If it falls in this range, we're going to send it to output port 2, and otherwise we're going to send it to output port 3. Now, the IP addresses are 32 bits long, but very often, especially for IPv4 addresses, we like to specify them in dotted decimal notation. And so what we use is you convert these numbers very simply to decimal. Okay, so in our case, we might notice, for example, this first address is 200. You have 128 plus 64 plus 8, that's 200. And then this next octet is actually 23, because this 1 represents a 16, this 1 represents a 4, this 1 represents 2, and that represents 1. So 16 plus 4 plus 2 plus 1, that gives you 23, and this is 16. So if I have an address from 200.23.16.0 to this is 200.23.23, and this is 255, then we're going to send it to output port 0. You may notice as well that if you look at these two rows of addresses, you would see that the first 21 bits, you have 8 here, 8, and then the first 5 bits in this third octet are similar, identical. Okay, so we have the first 21 bits there, and in this for this output port, you notice that the first 24 bits are identical. Okay, and for this row here, you notice that the first 21 bits again, 8, 8, and then the first 5 bits here are identical, and these will go to interface 2. Okay, so this leads us to the question: what happens in this case? The addresses kind of, divide up very nicely, but it's also possible that these could overlap. And so the question is, what happens if these ranges don't divide so nicely? Well, on the internet, what we use is something called longest prefix matching. Essentially, when we're looking for a forwarding table entry for a given destination address, we use the longest address prefix that would match the destination address. So to go back to this table, you notice here that the prefix here for these two was actually the first 21 bits. The prefix for this row was the first 24 bits, and the prefix here was the first 21 bits. So this table is simply derived from the table on the previous slide. Notice here we had the first 21 bits. This represents the first 24 bits, and this represents the first 21 bits. So the question is, which address will this destination address go to? Well, it turns out this destination address will go to interface 0, because that is the best match, right? You notice that matches the first octet, this matches the second octet, and the third octet for interface 0 must start with 00010, and that is exactly what we see here. So that's going to go to interface 0. On this address, this will go to interface 2, because this obviously matches the first octet. This prefix, this octet matches that second octet, and over here you notice the first 5 bits in the third octet match this entry here, so it's going to go to interface 2. Okay, so we will see in a few slides when we talk about IP addressing why longest prefix matching is used. Okay, so this gives you an idea basically of how routers work. They get in packets on the input ports. The forwarding tables are consulted, and the forwarding tables are actually installed at every port. So the forwarding tables are consulted, and then the packets are pushed out to the appropriate output ports. So in the next video, we're going to talk a little more about IP addressing. This ends this recording.